Hello students, this video is the third lesson in Unit 3. We're going to be reviewing auxiliary lines and transversals. We talked during the first lesson about the relationships between different angles when they're in parallel lines that are cut by transversals. This is an example of two parallel lines that are cut by actually two different transversals. And here's an example of an auxiliary line problem wherein there were two pre-existing parallel lines and you can draw a third parallel line between them, an auxiliary line, and then use that line to create new angles to help answer questions. The target here is a little bit long, but it's because it's a combination of the two learning targets from the previous lessons. We're going to apply transversal relationships like corresponding, like alternate interior, etc., to determine angle measures on a diagram. And we're going to justify our responses, meaning we're going to give a reason based on the diagram that we're looking at. The responses justifications are going to be like alternate interior angles or consecutive exterior angles, that kind of thing. We're also going to be using auxiliary lines. Those are helper lines to separate angles and apply relationships between new angles. The new angles are created by those auxiliary lines to find their measures. And honestly, if I was to boil this down to one single thing, we're going to be finding angle measures today, but we're going to be finding angle measures using all the different ways that we've learned about over the past two lessons. In the do now, it tells us that M and N, those two lines, are parallel to each other. That's what these two vertical lines mean. And the measure of angle 1 is equal to 150. Well, luckily for us, once we have that 150, we can find all of the other angles in this entire figure because we have two parallel lines that are cut by a transversal. We can find the measure of the remaining angles by using any of the methods that I've discussed previously. Pause the video, try to find all of these angles, and then come back to see if we got them right. Right, the first thing I want to remind you of is this big-small relationship wherein if you have two parallel lines and only one transversal, you can identify all of the angles as being either the big angles or the small angles. And the relationships contained herein are that all of the big angles are going to be equal to each other. They're all congruent. All of the small angles are all congruent to each other as well. And any big plus any small is going to be equal to 180. In this case, we know that the measure of angle 1 is equal to 150, so that goes here. And it stands to reason that since 150 degrees is the measure of this big angle, then all of the other big angles are also 150 degrees. Now, it stands to reason that all of the small angles are not going to be the same as the big angles because 150 degrees plus 150 degrees is well over 180. But I do know that every small and every big angle forms a straight line. So, for example, this big and this small angle are supplementary angles, which means all I have to do is subtract 150 from 180, and I get 30. So that means all of the small angles measure 130 degrees, or excuse me, just 30 degrees. All right, so we have a little bit of information, actually a lot of information about this diagram, and all we have to do is identify the relationships that are formed. Well, there are a couple of different relationships that I want to point out. Even though we found all these angle measures, let's just try to identify some of those relationships. For example, I'm looking at this big angle here and this big angle here. I know that those two big angles are outside of the two parallel lines. So those two angles are exterior angles. They're outside the two parallel lines. Another thing that I notice is that this big angle is on the left-hand side of the transversal, and this big angle is on the right-hand side of the transversal. So these two angles are an example of alternate, different sides of the transversal, exterior, outside the two parallel lines, angles, alternate exterior. All right, let's pick another pair of angles. How about this angle here and this angle here? Those two angles, one of them is big and one of them is small, are both on the same side of the transversal, so that means they are called consecutive, and they're both between the two parallel lines. So these two angles are consecutive interior angles. Consecutive meaning same side of the transversal, interior meaning that they are between the parallel lines. Now, we can find relationships for a lot of these pairs of angles. However, the relationships, all they do is inform us as to what to do with the measurements, whether they're equal to each other or whether they're whether they are supplementary to each other. So there go the rest of your answers there. All right, to review transversals, we saw this graphic already. It's just a color-coded graphic that identifies these different types of angles. Corresponding angles in red, alternate interior angles in light blue, sky blue, or cyan, vertical angles in yellow, alternate exterior angles in orange, etc. You would do well to memorize this diagram. But if you don't want to memorize the diagram, you should create flashcards with these different definitions. Remember that the definitions are important, but it is also important to remember what the definitions mean. If you can identify that two angles are corresponding, for example, that means you know that they are equivalent or congruent to each other. They have the same measure. If you know that this angle, this purple angle, and this purple angle are same side or consecutive exterior, you know that they add up to 180. So the useful thing is to identify the relationship and then identify the equation that you can set up based on that relationship. Take a look at this guided practice, identify the relationships they're in, and then solve for x. Pause the video and then come back to see if you got it right. All right, in this first problem, you should have identified that these two angles are consecutive interior angles. They are on the same side of the transversal, and they are between the two parallel lines. Consecutive means the same side of the transversal. Interior means that they're between the two parallel lines. I know that consecutive interior angles, according to this, also known as same side interior, they're equal to 180. So angle plus angle equals 180. Set up and solve. Check out this next problem. Now there's no direct relationship between this angle and this angle. First of all, this angle is on the outside of the two parallel lines and this one's on the inside. So we can't use interior and we can't use exterior because there's one of both. However, we can use another relationship. We know that this angle, 4x plus 5, is equal to other angles in this diagram. Specifically, this angle, which I'm going to highlight in blue, 4x plus 5, is the same as this angle here, because these two angles are corresponding angles. I'm able to make that allegation because I know that M and N are parallel, and I know that any two angles in the same position but different intersections, like top left on this intersection and top left on this intersection, are corresponding to each other. Once I do that, then I can identify one more thing about this situation. I can identify that this angle, 2x minus 11, and this angle, which is 4x plus 5, are supplementary. In other words, they form a straight line, and two angles that form a straight line in this way add up to 180 degrees. I want you to notice what this is sort of alluding to. In this example, we didn't have a direct relationship between the two angles, but we were able to figure out that one of the angles is equal to another angle in the diagram, and then we were able to use a pre-existing relationship that we knew about. In all of these problems, it's sometimes possible to say, well, I know this, so I'm going to fill in this information. And then once you fill in one other piece of information, you're going to be able to answer the question. All right, we're going to skip to the auxiliary lines because you're going to be doing the checks for understanding in class. Remember that auxiliary lines, which I still can't pronounce correctly, I'm sorry, are lines added to a diagram that can help explain a relationship or help identify a relationship. For example, when you're trying to identify a relationship when there's no auxiliary line, it's very difficult. But once you draw in this horizontal parallel line, I can say, well, I know that angle R is going to be equal to whatever this angle is on top. And I know that angle 130 is going to be supplementary to whatever angle this is on the bottom. Using these different relationships, I'm going to be able to find out the measure of the middle angle, the measure of any missing angle in the problem, just by drawing in an auxiliary line. So for the guided practice, I'm going to show you quickly where the auxiliary lines are going to go. I want you to try to draw them in first, though, so pause the video and try it out now. Okay. I know that there are two parallel lines here. They're horizontal parallel lines. I need to draw an auxiliary line so it goes through this point, which cuts the given angle into two separate angles. Bad aim, Mr. Scordian. I'm going to slide this one down a little bit. And then I'm similarly going to draw an auxiliary line that goes through this angle here. I'm going to draw it horizontally because these two lines happen to be parallel, and I draw it so that the auxiliary line is parallel to the other two lines that are there. I have angle 1 up here, and every time I create an auxiliary line, still can't say it correctly, I'm going to separate it into A and B. Or I'm going to separate the angle that's cut into A and B, I should say. Again, I'm going to separate it into A and B. And the reason I do that is because once I cut it up into A and B, then I can identify relationships between the angles that are created. Take a look at the first one and try to identify some relationships. Pause the video and I'll show you what those are. Okay, in this first one, I have a relationship wherein there's 144 and there's this angle A. It looks to me like I have two consecutive interior angles. And that's what I've identified here. I said that angle A is equal to 36. Now you might not see exactly why I found that, but once I find angle B, then I'll be able to combine those two angles in order to get the measure of angle 1. All right, moving on to the next angle here. This angle B is part of this shape where there's two parallel lines and a transversal cutting them. If I look at this relationship, it's in that Z shape, and you should remember that that Z formula is also, or the Z theorem, is also known as the alternate interior angles theorem. And I found angle B is equal to 56 degrees. Now that I know that angle A is 36, and I know that angle B is 56, I can say, well, angle 1 is just a combination of A and B. In other words, I'm using the angle addition postulate. And since angle 1 is equal to the sum of angles A and B, I just added A and B together, and I got 92 is equal to the measure of angle 1. I can do the same thing here, except I already know the measure of this angle in between. I'm trying to find the measure of angle 2. And I know that angle B and angle 2 have a special relationship between them. In fact, angle B and angle 2 correspond to each other. So I know that whatever angle B is, it's going to be the same as angle 2. I just don't know the measure of either of them, so I can't start there. But I do know this angle up here. So this angle 35 has a special relationship with this angle, which is angle A. Guess what? This 35 is on the top right-hand side of that intersection. Angle A is at the top right-hand side of that intersection. They are corresponding angles as well. Once I know that this angle A is 35 degrees, I can say, well, A plus B is equal to 72, right? So A is 35. I can figure out B by using the angle addition postulate. So there's angle B, which is equal to 37 degrees. As I said previously, I know that angle B and angle 2 are equivalent to each other because of corresponding angles. I'll write that out and solve the problem. So I was able to figure out that angle 2 is equal to 37 degrees. And fixing an earlier mistake, I did put in my units. I don't want to go too far into the checks for understanding, but I do want to make sure that you understand this well enough. So I'm going to go to one of the problems in the problem set and review that. All right, I've moved on to question number 6 in the problem set, and I want you to observe a couple of things. First, I know that these three are all parallel lines. We observed that they were parallel lines, and it says it in the problem. I also want you to think of this line that is this person windsurfing as a straight line that's cutting through all of those parallel lines. In other words, this is a transversal. Here is the transversal. And one other thing that I want you to see is that an angle of 70 is given to us. This angle for this intersection is on the bottom left-hand side. That means that it is going to be corresponding to this angle. So an easy way to figure out half of this problem is saying, well, I know that angle 70 and angle 2, angle which is 70 degrees and angle that is labeled as 2 are the same or congruent. One thing that you should also observe is that this angle, angle 1, is not the same, but this angle, angle 1, which I'll highlight in a different color, has a special relationship between itself and angle 2. These two angles are between two parallel lines, and they're on the same side of the transversal, making them consecutive interior angles, which means whatever their measures are, they have to equal to 180. So if this measure is 70, this measure has to be 110. Using the equations here, or the expressions here, you should be able to solve those equations fairly easily. All right, this was the lesson on Unit 3, Lesson 3, which is on auxiliary lines. One day I'll learn how to say this word, and transversal problems. Good luck studying.